Okay, let's dive in and actually compute some matrix products. So here I have the matrices in the other way around. So the m by n matrix I'm calling A this time, and the n by p matrix I'm calling B, just so that when I write the product, it's in alphabetical order. That's really the only reason. But that means that the formula for the ijth entry of this matrix product is the sum from k equals 1 to n of a, I, k, b, k, j. All right, so let's work out what are the product of these two matrices. So we're going to work out b times a and a times b. B, remember, so b is 2 by 2, and a is 3 by 2. So b is 2 by 2, a is 3 by 2. And remember, for a matrix product to be defined, these inside sizes have to match, because for this sum to even make sense, right, for this sum from 1 to n to make sense, since this index shows up in these two places, there had better be the same number of things when this index goes from 1 to n. Well, in this example, with the matrices this sort, this way around, there aren't the same number, right? B has 2 columns, but A has 3 rows. And so this sum just doesn't make sense for the product this way around because these numbers don't match. So for these particular matrices, A and B, the product B times A doesn't exist. It's just not defined. Okay, well, let's work it out the other way around. So A times B. So here we've got 2, 1, 0, 3, minus 5, 2, times the matrix 6, 1, minus 1, 3. Okay, now we know since this is 3 by 2 and this is 2 by 2, the resulting matrix is going to be 3 by 2. Remember, the inside matching sizes get used up and you're left with the outside sizes, so 3 and 2. So we need space for a 3 by 2 matrix. Okay, now let's work out this first spot. Right, this is the 1, 1 spot. And what our formula says is, to get the 1, 1 spot, we need to use row 1 from A and column 1 from B, like this. And what we do is just multiply corresponding entries and then add them up. To do this in my head, what I do is I take these entries, so 6 and 1, I sort of turn this column sideways, like this, and then I sweep it downwards, and every time I hit a row, I multiply. So 6 times 2 is 12, plus 1 times 1, that's 1. Okay, now let's figure out the second row first column. Well, we're still going to use the first column from B, but since we want the second row of our matrix, we move down to the second row of A. So now I take this 6, 1, and I slide it down further until I hit these entries. So 6 times 0 is 0, plus 1 times 3 is 3. All right, now for the 3, 1 entry, I'm still using the first column of B, but now I'm using the third row of A. So I take my column, which I've turned sideways, and I slide it all the way down to the bottom. So 6 times minus 5 is minus 30. And then plus 1 times 2 is 2. So this is a 3 here. Okay. Now to work out the second column, I do the exact same thing, except I use the second column instead of the first column. So now instead of a 6, I have a minus 1, and instead of a 1, I have a 3 over here. You can see that what we really need to do is take this column from B that I've turned on its side and just slide it down and hit every row. Right? Every time I hit a new row, I get a new entry in the matrix product. So minus 1 times 2 is minus 2, plus 3 times 1 is 3, so that's for the first row. For the second row, minus 1 times 0 is 0, plus 3 times 3 is 9, and then minus 1 times minus 5 is 5, plus 3 times 2 is 6. So I get 13, 3, minus 28, 1, 9, and 11. Okay, so you know, this formula for the matrix product right here, it defines the matrix product, but it's not very useful for actually calculating matrix products, just because it makes it hard to see what's actually going on, right? So I would highly recommend that you find some trick for calculating matrix products that works for you. And this is just the trick that I like. This is the trick that works for me, that lets me compute matrix products efficiently. So take a column from the matrix on the right, turn it sideways, and then sort of sweep it downwards. And every time you hit a row, do this multiplication and addition stuff. And that gives you, as you sweep one column downwards, you get every entry in that column in the product. And then just move over to the next column, and that, when you sweep it downwards, then you get the next column along. And just keep doing that until you're done. Okay, let's look at another example of calculating a matrix product. So for this one, we really need our trick. So doing this using the formula and the definition would be a nightmare of bookkeeping. But using our trick, it's not that bad. So first, let's check that this matrix product is defined. So this one is 3 times 3. This one is 3 by, sorry, not 3 times 3. It's 3 by 3. The second matrix in this product is 3 by 4. And the inside sizes match. So this matrix product is defined. And the resulting size is these outside sizes. So it'll be 3 by 4. So I need enough vertical space to fit in 3 rows. So now I'm going to take my first column, 1, 0, 4, tip it sideways, and then sweep it down. So 3 plus 0 plus 4 is 7. And then go down to the next one. 1 times 4 is 4 plus 0 times minus 16. This is a 4. I'm sorry, this should be a minus 4. So let me do that again. 3 minus 4, this should be minus 1. Okay. And now 4 plus 16, that's 20. And then 0 minus 8, that's minus 8. Okay, that's using the first column, and it gives me the first column. Now use this, so now let me get rid of my column tipped sideways, because I'm going to move to a new column. We'll move over to the second column. So minus 2, 1, 0. And then do the same thing. So here's minus 6, minus 2 is minus 8 plus 0, so minus 8. And then minus 8 plus 6 is minus 2 plus 0, minus 2 down here. And then 0 plus 1, 0, so that's 1. All right, now I'm done with this column, so let me erase these. And then we'll move to the next column. 1 minus 3, 2. So 3 plus 6 is 9, plus 2 is 11. 4 minus 18 is minus 14. Minus 8 is minus 22. Okay. And then 1 minus 3 plus 4 is 1. All right. Now I have to tell you that unless the numbers are big and messy, I actually don't write down the column that I'm tipping on to the side. I just sort of mentally move this column over and then sweep it downwards. If it helps, you can actually take your fingers and go across one row and down a column and do the addition and the multiplication and addition as you go. So this one, let's try to do it all in our heads. So 0 times 3 is 0, minus 6, plus 5, so that's minus 1. And now for the next row, so 0, that's 18, minus 20, that's minus 2. And then 0, plus 3, plus 10, that's 13. Okay, so you can see that even though there's a lot of operations in a matrix product, actually computing a matrix product isn't that bad if you sort of have a little practice and know how to move all the rows and columns around.